Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's, or Christmas Day's, easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called a Christmas tree, and yes, this is another Christmas tree, so if you did the easy puzzle, the very easy puzzle today, this is another one. It seems to be that's the theme that most setters use for Christmas, because I was looking for Christmas stuff, and basically these were the only Christmas trees were showing up. So I guess there's a lot of Christmas. I mean, it makes sense, I guess, because you have green with the German Whisper lines or the Whisper 5 lines, and then there's a lot of ornaments you can always put on the Christmas tree. But it's basically just been like Christmas tree puzzles for a while, so here's another one. Let's get to the rules. Oh, so it's a Christmas tree by Red Barchetta. And here are the rules. We have normal Sudoku and normal variant rules apply. So these are typical Sudoku and variant rules. We have Sudoku rules where you need to place a digit in every cell such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have German whispers, where consecutive digits on green lines must differ by 5 or more. So, for example, if this were, say, a 3, this would have to be an 8 or a 9 to maintain, because those are the only digits that are 5 or more away from 3. And that's an example of how German whisper lines work. We have killer cages, where digits in cages do not repeat and sum to the value if given in the top left cell of the cage. So, for example, these 6 digits must add up to 25, these 3 must add up to 12, and these 6 digits must add up to 25. We have Kropke dots, where digits on red dots, so this is the variation, are a 2-to-1 ratio. Or I would say red dot separates cells, which must have digits in a 2-to-1 ratio. So these are the equivalent of black Kropke dots. And then you have Kropke dots where digits on white dots are consecutive. So, for example, if this were, say, a 4, this would have to be a 2 or an 8 to maintain the 1-to-2 ratio. If, say, this was a 3, this would have to be 2 or 4 to be consecutive with the 3. And we also have digits separated by an X summed to 10, and digits separated by a V summed to 5. And not all XV clues are given. So, for example, if this was 3, this would have to be 2 here. If this was, say, 4 here, this would have to be 6, because these two must add up to 5 because there's a V that separates them. These two must add up to 10 because there's an X that separates them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, in row 8, we have 4 sets of digits which are separated by an X. That means those must be the digits 1, 9, 2, 8, 3, 7, and 4, 6, which leaves this digit as a 5. Let's look at box 2. In box 2, we have 6 digits which add up to 25. The remaining 3 digits, then, must add up to 20. Now, on a German whisper line, or a whisper 5 line, you always alternate between low digits and high digits in normal Sudoku. And the reason is, what digits can be next to a low digit? Low digits being 1 through 4, high digits being 6 through 9. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can be next to 9 only. So whatever low digit you have, it's always going to be next to a 6 through 9, which are the high digits. And then you'll have vice versa, right? 6 through 9 also has the same relationship with 1 through 4. So these two digits are the same set. And can you ever have two lows here? No, because that would be maximum of 3 plus 4, and then you have a maximum of 9 for the other digit. So 3 plus 4 and 9 is 16 at most, when it should add up to 20. So these have to both be high, which makes this low. It also makes these low, which makes these high. These are low. Oh, and we should have actually probably been able to say, oh, we have sets here adding up to 5. It's either 1, 4, or 2, 3. So these are low, too. Anyways, these are both high because they're next to a low on a whisper 5 line. These are both low because they're next to a low digit on, sorry, a high digit on a whisper 5 line. That makes these high. These are high, these are low. These are high, and these are low. Which means to add up to 10, these must be high. Okay, so this digit is consecutive with another digit, but it could be 1 through 5. Since this is 1 through 4 here, 1 through 4 here, this cannot be 5 here. So one of these two has to be a 5. This cannot be low because of the 4 lows already in row 5. So this must be a high digit. And these have a difference of at least 5, and they add up to 10. The only possible combinations are 1, 9, and 2, 8. 3, 7 has a difference of 4. 4 and 6 has a difference of 2. So this must be a... So this has to be 1 or 2. This is 1 or 2, and this is 8 or 9 here. Well, this pair of digits both have to be low. This cannot be 1 and 2 because that would eliminate all possibilities for this cell. In fact, we actually have all the lows already. We have 4 lows in column 3. So the rest of the column cannot be low. These both are low and are in a 1 to 2 ratio. The only possible combinations are 1, 2, and 2, 4, and 1, 2 would eliminate all possibilities for the cell. So this has to be a 2, 4 pair, which eliminates 2 and 4 in the rest of the column. This can't be 2, this is 1, which makes this 9, which makes this 8, and makes that 2 to add up to 10. That leaves this as 3, which must add up to 10 with 7. We have 4 lows in column 7 also. And again, the only sets of 10 which add up, which have a difference of 5 between them, are 1, 9, and 2, 8. So this must be a 1, 9, 2, 8 pair. Oops. So we have 1, 2, 8, 9. 1, 2, 8, 9, which eliminates 1, 2, 8, 9 in the rest of the row. So this has to be 4 and 6. 4 can only be next to 9 on a whisper 5 line, so this is 9 and 1. This is 2 and 8. 8 is in a 1 to 2 ratio with 4. 3 is in a 1 to 2 ratio with 6. This cannot be 2 or 4. This becomes a 1, 3 pair. 1 and 3 add up with 2 and 4 to add up to 5. We have a 2, 4, 2, 4. Yeah, this 2, 4 means this can't be 2 or 4. This digit is next to 2 unique digits on a whisper 5 line. 4 is only next to 1, can only be next to 1 unique digit on a whisper 5 line. So this must be 2, this is 4, this is 1, this is 2 and 3. 2 is only consecutive with 1 or 3. This can't be 1 because of 1 in the box. So this is 3, which makes this 1. This is low, whereas the 5 in box 5 can't be here, so it must be here. 4 can only be next to 9 on a whisper 5 line, so this is 9. 1 can be next to many of them, so these are 6, 7, or 8. 2 could be next to 7 or 8 or 9, but this can't be 8 or 9, so that makes this a 7, which eliminates 7 here. 3 can only be next to 8 out of 6, 7, or 8 on a whisper 5 line, so that's 8, which makes this 6. We have to have a 4. So these must both be high. Can you have 6 and 7 is the question. 6, 7 is 13, which would have to add up with... Okay, it could be 6 and 9, though. This can't be 5. So to add up to 20, we have 3, 8, 9. 4, 7, 9. 5, 6, 9, and 5, 7, 8. Well, 5 cannot be here either case, so this must be a low digit. So this is 3 or 4, and we're guaranteed a 9 here. So this must be 9. And it cannot be 4, 7, 9 because we already have a 7 in the column there. So it must be 3, 8, 9 to add up to 20. So this is 3, 8, 9. This is a low, which has to be more than 5 or more away from both 2 digits. So it's either 1 or 2. If it's 2 here, this could be 1. If this is or 4. If this is 1 here, it must be 2. Remaining digits in the box 5 are 4, 6, and 7. So that's 6 or 7. This is 4, 6, 7, which eliminates 4, 6, and 7 in the rest of the column. So this can't be 4 here. This becomes a 1, 2 pair here. So this is also low. Remaining digits in column 5 are 8 and 9. Okay. Remaining digits in column 3 are 5, 7, 8, 9. No 7 or 8 here. 5, 7, 8, 9. No 8 or 9 here. This cannot be 9 here because that would force this to be a 1, 2 pair to add up to 12 with it. And that would eliminate all possibilities for this cell. Column 7, we have 5 through 9 remaining. 4 is in a 1 to 2 ratio only with 8 out of those. So this is 8. This cannot be 6 or 8 or 9. No 8 left here. This can't be 9. 8 eliminates 8 here, so this is 9, which makes this 8. 7 eliminates 7 here, so it's 5, which eliminates 5 here, so that's 9. So there's no 9 here. There's no 5 here. So to add up to 20 here, which is 45 minus 25, you have a 9, 7 with 4, or 9, 6 with 5. So this is 4 or 5 there. Remaining digits in box 7, we have 1 and 5. 5 can't be here because of 5 in the row, so this is 1, this is 5. Remaining digits in row 7, we have 2, 3, and 4. This can't be 2 or 3 because of 2 or 3 in the column, so this is 4. That leaves us as a 2, 3, 2, 3 pair here. In box 8, we have 1, 2, and 3 remaining, but 2 and 3 cannot be here. So this is 1, which makes this a 2, 3 pair. We have in row 9, 2, 3, and 7 remaining. In column 4, we have 4 and 6 remaining. In column 6, we have 5 and 7 remaining. So this is 10, 13, plus 12 is 25. That works. What else do we have? Adding up to 12 could be 1, 3, 8. No 1, 2, 9 again, because that would eliminate all possibilities for this cell. 1, 3, 8 works. 3, 4, 5 does not work, because that would eliminate all possibilities for this cell here. So it's guaranteed to have 1 or 2. 1, 3, 8, 1, 4, 7. But the problem if with 1, 4, 7 is that would force this to be 5 here and this to be 5 here. And that therefore we'd have a duplicate in row 1, which is not allowed. So it cannot be 1, 4, 7. 1, 5, and 6 does not work because of the same problems. 1, 5, 6 would force this to be 4 and force that to be 4, and we'd have a duplicate in row 1. So just 1, 3, 8 for 1. For 2, 2, 3, 7 works. 2, 4, 6 does not because this has to be 5, 7, 8. And that's it. So these are the so this has to be 3 both times. So this is guaranteed to be 3. That's 3 in the corner. We celebrate because we're now close to solving it. So we have a 1, 2, 1, 2 pair here, which eliminates 1 and 2 in the rest of the row. Also, where can 9 be in row 1? It cannot be here because we have a 6, 7, 9 triplet in the box. These can't be 9 and this can't be 9. So 9 has to be in row 1 here. Which means this can't be 9. Where's 9 in row 2? Cannot be here anymore because of 9 in the box. Can't be here because of 9 in the box. Can't be here because 9's in the column. So 9 has to be here. So the remaining digits here cannot be 6 or 7. Cannot be 1, 2, or 3. So it's 4, 5, and 8, right? No 6, 7 because of the 6, 7 pair in the box. Remaining digits in column 1. Actually, let's do remaining digits in row 6. It's 4, 6, 7. Okay. That's not that helpful. Remaining digits in column 1. 4, 6, 7, 8. But this can't be 7 or 8, so this is 4, 6, 4, 6, 7, 8, 4, 6, 7, 8. Oh, none of these could be 4 because of 4 in the box. This becomes a 6, 7, 8, 6, 7 pair, which eliminates 6, 7 here. So this must be 8. That eliminates 6 in the column, so this must be 4. The rest of box 4 contains 5 and 3. 3 can't be here because of 3 in the row. So this is 5, that's 3. The rest of column 2 is 1, 2, and 6. Okay. Remaining digits of row 5. We have 6, 7, and 9. This can't be 6 or 9, so this is 7, which makes this 6. That eliminates 6 here, 6 here, 7 here, and 7 here. We have a 2, 3 pair in box 9, which eliminates 2 and 3 in the rest of the box. This can't be 2 or 3, it's 7. That leaves this as a 9 in column 5, or row 5. We have 4, 5, 6 remaining in row 4. This can't be 6, though, because of 6 in the column. We have a 4, 5, 4, 5 pair in column 8 now, which eliminates 4, 5, and 8, 4, 5 in the rest of the column. So this is 1, 2, 3, 1, 2, 3. No 3 here because of 3 in the row. Okay. We need a 6 in row 1. Where is it? Can't be here, can't be any of these cells, so 6 has to be here, which forces this to be 4. Remaining digits in row 3. 1, 2, 5, 6, 7. And this can't be 1 or 7. So we have 2, 5, 6 there. Again, this is 479 or 569. This cannot be 6 because of the 6-7 pair in the box. Remaining digits in column 9. We have 2, 3, 4, 5, no 6 or 8. 4 can't be here because of 4 in the row. Hmm. If this is 5, say this is 4 and 7, then this could be this. If this is 4 and 7, that would force this to be 5, which would force this to be 7, which would force that to be 8. So that could not be 8 in that instance. It would have to be 5, right? 4, 7 makes this 5, 7, which makes that 8, which makes that 5. 5, 6 makes this 7. So 5 makes this 7, which makes that 8. So this is always 8 here, which makes this 1, 8. So this is 4 or 5 here, which eliminates 4 and 5 in the rest of the row. This can't be 5. That's 7, which is 5. 7 eliminates 7 here. This is 8 and 1. 1 eliminates 1 here. So it's 2 and 1 here. Neither of these can be 1 anymore. This can't be 1. Where is the 1? This 4-5 pair eliminates 4 and 5 in the rest of the box. This can't be 5 then. This is a 2. Which makes this 1. 2 eliminates 2 here, so it's 6 and 2. This can't be 5 or 8. It's 7, which makes this not 7, so it's 5. 6 eliminates 6 here, so it's 7, which makes that 6. So this must be 5 and 6 and 9 to add up a 20. So this is 4. 2 eliminates 2 here, and 2 here, so it's 3 and 2, which eliminates 2 here, so it's 3 and 2. 2 eliminates 2 here, so it's 3. This has to be 8. 5 eliminates 5 here, so it's 4, which eliminates 4 here, so it's 6, which makes this 5. 4 eliminates 4 here, so it's 7 and 4. 7 eliminates 7 here, so it's 6 and 7. Merry Christmas! Yeah, Merry Christmas, everybody. And I hope you enjoyed this solve, and I hope you have a Merry Christmas, and I'll see you next time on Frank Puzzles. Take care.